Welcome everybody, Mr. Allen here. I'm going to quickly introduce the idea of the factor theorem today. If you've gone through the questions that were posted that asked you to do simple substitution, you will see that the values we're getting in each substitution line up nicely with the remainders we got in the last section, so that we can establish this idea of the remainder theorem, which is any value that is substituted into a polynomial will give you as an answer the remainder if we divide the original polynomial by x minus that value. So in this case, x minus -2, which would be x plus 2, will give me a remainder of 13. That's what we saw in 1b in last day's work. What we really want to pull from this then is when we get an answer of 0, subbing in the 3 in this third case, got me an answer of 0. 3 to the exponent 3 is 27, minus 7 times 3, 21. So 27 minus 21 minus 6, which is the answer 0. And what that tells me again is I'll have a remainder of 0. Not no remainder here, a remainder of 0. But it means really that when we do the division of x cubed minus 7x minus 6 divided by x minus 3, it divides perfectly evenly, and x minus 3 is actually a factor of the original expression. So again, just sort of an explanation of what the factor theorem actually says. If p at a, so if we substitute the value a into a polynomial and get the answer 0, that means that the original polynomial divides evenly by x minus that value. So again, a 2 in here means that my polynomial will divide evenly by x minus 2. A -3 in here means that my polynomial will divide evenly by x plus 3, x minus -3, x plus 3. And so if the question simply asks me to factor something, I'm basically going to test values in the expression to see if the remainder is going to be 0. So in this case, I'm just testing the value 1, substitute a 1 in for all the x values, and all I'm interested in is whether I get 0. If it's not 0, I don't really care what the number is. I can see pretty quickly I'm going to have a 1 and a 2 and then some subtractions that are noticeably bigger. I can move on. And I can test 2 or -1 next. I'm basically trying nice small numbers that'll divide evenly into -6 because that will make the question a little bit easier. Here when I plug in the 2, I get 8 plus 2 times 4 is another 8. So it's 16 out front, minus 10 minus 6, that is 0. Once I know that x minus 2 is one of my factors, I can use synthetic or long division to simplify. Again, in synthetic division, of course, I'm using the actual root here. I'm using the 2. If I were doing long division, I would divide by the x minus 2. And I go through the process. The one key, of course, is here I must get a 0 remainder. The reason I chose to use the 2 is because I saw that I was going to get a 0 remainder. Obviously, then when I actually do the calculation, I'll need to end up with a 0 remainder. And so the P2 tells me that x minus 2 is one factor. The answer to my division is the second factor, 1x squared, 4x, 3. I could use my factor theorem again at this point, but because I ended up with an ace quadratic, something that I can easily factor using methods from grade 10, grade 11, I'm just going to go ahead and finish it up that way. Looking for two numbers and multiply to the 3 on the end, add to the 4 in the middle, 3 plus 1, positive 3, positive 1 are my answers.